Okay, I'm going to walk through the activity of making this circular plate with holes, and I'm going to pretty much make it the way it's here, but I'm going to add an extra hole in the middle to cover a couple other hole types at the same time, and that hole will be placed at the center. So just be mindful that this activity has 5 different holes defined. We're going to have 6. We'll add one in the middle. First, we just need to make a cylindrical block that is right here. You've got a diameter of 4. I'm assuming this is inches, should be. So 4 inches extruded to a depth of 1.5. So we're going to start a new sketch, and we're going to make a circle. Oh, I missed the origin. I want to grab that. I'm going to type in a diameter of 4. I'll zoom out a little bit, finish sketch. E to extrude, or press extrude up there, and we're going to go 1.5. Okay. And then I'm going to, we see this circle here that all the holes are placed on has a diameter of 2.5. So I'll make a construction circle just to kind of guide that. I'm going to start a new sketch right here, grab a circle tool again, and go to a diameter of 2.5. Okay, I'll make that, and I'm going to make it dashed simply by selecting it, left click, and then a right click on it to choose construction. That'll make it a dash line. And then I'm going to put a point on that circle, and I'm just going to happen to have it be straight above the origin. Okay. And then I will use the circular pattern tool in my pattern panel, the circular pattern, to pattern that point around the center of the circle as my axis, and I'm going to make a total of 5. Okay, and I'm going to go ahead and make a point at the center as well. And so each of those points is going to turn into a hole. I'm going to hit finish sketch. Now, to make a hole, I'm going to use the hole tool. If I go ahead and press the hole tool with all these points in a sketch, an unused sketch, and none of them selected, Inventor thinks I want to select all of them, and notice all of them start previewing whatever is currently chosen in the hole menu. And if I don't want to make all these the same, before choosing the hole button, I can go and select a single hole. It's hard to tell, but notice that that one is like a light blue. Okay, right here is a light blue, where the others, it's a different color, more of a dark blue. Okay, if I left click off to the side, it deselects it, and I'm going to actually start with the top one. Okay, so then if I press the hole tool, it's only that one. Okay, so back to this document here. I've got these notes. The first hole is going to be a simple hole called a through hole. And if you scroll down in this document, you'll get some different screenshots and snips to help you see the menus, etc., that I'm going to be showing. But you'll also get a chance to pause and see them as I have them on my screen. Okay, so mostly I'll probably stay right on this view. Okay, so the first one right here, I'm at the top, is just a 1/4 inch diameter through hole, just a very simple hole. So right here I'm defining the diameter as a 1/4 inch. Instead of a depth, under termination, I'm just going to say through all. That makes it a through hole. And different options here. So I've got to maybe click. It should show you names. Like there you go. That's a counter bore. If I hover, that's a drilled hole, just a simple hole. Simple hole down here as well. So that's all we want. It's just a simple hole, 1/4 inch all the way through. Hit OK. All right, that's our first type. Now, one of the things that happens is that sketch that had all the other points just disappeared. I can't see it. That's because it's been consumed. Once you use a sketch for a 3D feature, it kind of consumes it. So now it's embedded underneath that feature. Instead of having to make a new sketch, we can actually come back and use this one. To do that, I have to expand that so I can see it. I right-click on the sketch, and I choose the option to share the sketch. That will allow me to use that sketch geometry again for more 3D features instead of having to recreate the same sketch over and over again. So I will share the sketch, and it makes a copy of it in the browser, brings it up outside of being embedded under there, and it is automatically visible. I can right-click on it, and I can check or uncheck visibility to make it visible or not. Since it's a shared sketch, it's going to stay visible unless I turn that visibility off. Okay, so for the second hole, I'm going to work my way clockwise. So I'm going to choose the next point, and I'm going to hit the hole button. And let's go back. This one is going to be what's called a counter bore hole. Okay, and so I've got two different diameters. That's because the counter bore has a larger, shallower hole at the top, basically to recess the head of a bolt, so that the top of the bolt is at least flush with the surface, if not maybe recessed under the surface. So the larger diameter is the counter bore, and the smaller diameter is going to be for the at least deeper, if not through hole. So I've got 3/4 and 3/8 here. So I'm going to choose the counter bore hole, and the larger is supposed to be, that was the 3/4, right? So 0.75. And then the skinnier, deeper hole is the 0.375, which is 3/8. And let's come back and look and make sure our depths are right. The skinnier hole is a through hole, goes all the way through. The counter bore is a 1/4 inch depth. So right here, this dimension you can see is showing the depth of just the counter bore, the place to receive the head of the bolt. So that's set right. And then the distance of the other hole right now is set to through all, which is what we wanted, a through hole. So I'll hit OK, and that'll make that. So let's choose the next hole. We're going to continue our way around. Choose hole, and go back and look. This one has a different symbol, looks like a V. This one's called a countersink. Generally, it's used to receive the shape of like a lot of screws, wood screws, a drywall screw. Just certain screws have a conical shape, and so to have those seat well into the material, we'd want to leave that profile behind. So that's what we're going to do. Again, our 3/4 and 3/8 are the same distances, but this time we're not defining I guess a depth, because it's going to come to a point. So we're defining the angle. The angle actually would kind of define the depth as well. If we had changed the angle, it's going to, the V, it'll take kind of less depth or more depth to come together. So we have 3/4 of an inch at 82 degrees. So we're going to choose the countersink right here. And we've got the 3/4 inch. These are just defaults that happen to already pop up. So boom, 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 I'm all there. And did I want a through hole? Yes, I did. So I really don't have to change any settings. These are all what I wanted. But just go through and verify. You can go ahead and change, you know, the angle and kind of just see the preview and just to kind of see how that might affect it. So you can play around with that. But I'm going to settle out, hit OK. Let me go ahead and choose the next point, hole. Working my way around this one. This note is a threaded hole. This one has threads for a screw or bolt to actually twist in. And so this is a thread note. This right here tells us the diameter, and the next number tells us the number of threads per inch. So it's 20 threads per inch. This is a note to tell us if the threads are considered coarse or fine. The C stands for coarse. And this value right here gives us the depth. This little, it looks like a T symbol with an arrow on the bottom. Think of that as being the surface, and we're arrowing down. We're saying how far down from the surface. This is actually the depth of the threads. So we're going to make this a through hole, but we're going to make the threads only go down 3/4 of an inch, so about halfway, right? Okay, so we want a 1/4 inch diameter, tapped or threaded hole, where the threads only go halfway. Okay, so to do a tapped hole, it's down here in the bottom right here. This one is threaded. And thread type, the ANSI unified screw threads is correct. Under size, the size is the diameter. The designation is going to correlate to the size. So notice that 0.375 is really 3/8. So all of these sizes right now are 3/8. So you need to choose the size, the diameter first. So I need to go find a 1/4 inch in the menu. And once I choose that, then this is all quarters. And it was actually already on the correct one. 1/4 by 20. And there's a class here. This says class 1B. So we can change that class of threads. You can control if it's a right hand or left hand. We'll leave it on a right hand thread. Do we want the threads to be full depth? I'm going to leave that unchecked so that the threads are not full depth but only halfway. Okay, and the face of this hole does not look like it has a countersink or counter bore. So on the top, I'm going to do a simple drilled hole. Okay, and then the distance I'll leave on through all, but the threaded, you can see this field, if you trace that over, is showing the threaded part. So we wanted that to be half, which is 0.75. Okay, so we've got half of it threaded, otherwise we're through all. We're a 1/4 inch diameter, a 1/4 by 20 threads, class 1B, right hand. That's righty-tighty, lefty-loosey. Left-handed thread, it would be backwards. Okay, choose OK. Got 2 more to go. I'm going to choose this one, hole tool. We'll switch over, and this one here, they actually don't have a note on it, but it's supposed to be a clearance hole. So I guess if we could go ahead and scroll down in your document to see that one, it should be the last one. Okay, under these different hole types, a simple hole, the next one is a clearance hole. That's trying to make sure something passes through it. So this might be a hole in a part made so a bolt, for example, might pass all the way through it because it's trying to get to something behind or underneath this object. Okay, so this is the one we want to choose here. So right here, I want a clearance hole. All right, and then the size. Did they tell us here? The size is a 1/2 inch for a hex head bolt. So I'm going to choose a 1/2 inch. And a hex head bolt is what we want to pass through. The fit is normal. That's what it was on. ANSI unified screw threads. Yep. So I'm keeping all that the same. And the distance is going to be through. Okay, it's kind of the idea of the clearance holes to make sure that something can pass through it. And based on me choosing these fasteners that would pass through, this has already been set for me. I didn't have to adjust that. Okay, so that's been determined, and I think I'm good through all, etc. Okay, so we'll choose OK. And made that. The last one I'm going to make is going to be at the center. It's the only point not there, so I don't think I have to select it if I just choose the hole tool. There you go. And this time we're going to do one called a spot face. A spot face is like a counterbore, except it's shallower. And I will make this, how about a 1/2 inch? And I'll make the narrow diameter 1/4 inch. If you just follow me, I'm going to choose this is a 1/16 of an inch. I'll leave it that. So that's not going to be deep enough for the head of a bolt to actually have the top of it flush with my surface or even recessed. It's going to stick out. It's really just making sure that I have a flat surface for the underside of the bolt to really just be flat against the material. Very good to use if you are drilling a hole where the outside face has any curve or complexity to it, to basically create a flat spot for the bolt or screw to just tighten up snug against it. Okay. Now I'm also going to make this hole be what's called a blind hole. It's blind because from the back side you won't see it. So I'm not going to have it go all the way through. I'm going to change the distance. So I have to switch from through all to distance. And we're going to make the overall depth be only that 0.75 halfway through. Okay, and then I can also, the drill point at the when the hole terminates inside, I can choose now with a blind hole if it's going to be left with an angle. Certain kind of tips of drill bits will leave this little conical shape at the bottom. Okay, versus using a drill bit that will make sure it cuts out a nice flat bottom. I'll go ahead and put it on the flat bottom and then hit OK. Okay, there you go. So we've created our shape. Oh, that one's not a through hole for some reason. Let me go back to, I can hover and find the holes. If I just hover over my browser, they highlight. Let's edit hole 4. So I right clicked. I don't need to edit the sketch, just the feature, edit feature. And let's change the distance of that threaded hole through all. It was the threads I wanted to be halfway, but the hole I did want to go all the way through. There you go. Now I can see light through all of them except this one. And if I rotate around to the back, you can see that I see 5 holes, not this one. That one's called a blind hole. Okay. To finish this assignment off, we're actually going to put this onto a drawing sheet and show how to use the hole notes, hole and thread notes. So save it to a folder if you're choosing. Okay. And I'm going to go ahead and just kind of save a second copy of this. I've already done this activity. And then we are going to start a new file. So go back to home if you want. New, and it's going to be our Edgewood ANSI drawing sheet, where you can go ahead and put in your name. The title, I'm going to call it CircularPlate with holes. The date is, let's see, today is actually the 22nd of January 2018, and I'll leave the class period blank for now. Okay, so we're going to bring on a base view, and it probably, since I just saved that, is going to guess right, which it did. And I'm going to do 3 views. I'm going to do this front orthographic face. I'm going to do a side view so I can dimension the depth of the part. I'm going to give an isometric view. I'm going to right click and say OK. I'm going to shade the isometric, so I edit view, choose the shading, etc. Okay, now here's the nice thing. So I will go to annotate, so the dimension tool. You could put the dimension tool on a hole and it does it, but the problem with that is it's not going to give you some of the detail that we want. So right click escape, I'm going to choose the dimension tool only for the physical object, not for the holes. So I will go ahead and let you know what the diameter of this object is, dimensioning, and I'll let you know the depth over here. Okay, but in terms of getting these hole notes, we can get all the detail, all the information, the threads, the countersink, counterbore, all the different depths by using right here, feature notes. So a hole and thread note, it's super easy. So hole and thread notes. Now all I have to do is click on the perimeter of that hole, and that's it. Boom. So it lets me know the diameter, tells me the depth. It's a through. Watch the next one. This one was the counterbore. So you see the little, it's a rectangular, the open rectangle. That means counterbore. Gives me 2 different diameters. Gives me 2 depths. One depth is through, the other is shallower. Okay, let's grab this one here. This is the countersink. You're going to see the countersink symbol with the pitch of the angle there. The pilot hole, you might call it, the through hole. Okay, depth. This is the tapped hole. So notice we get all that detail. The diameter, the threads, the class type, the depth of the threads, etc. Here's our clearance hole. And let's come in here and get the blind hole. This blind hole is also a spot face. So you can notice the spot face is really the same thing as a counterbore in terms of kind of the shape that you're drilling out. It's just that it's shallower. And so they go ahead and put that SF for spot face to let us know that it's a shallow. They don't tell you the exact depth of it. It's just usually a very shallow cut just to ensure that you got a flat surface. Okay? So that's that. With this assignment, what am I going to have you do? I'm going to have you print this out. So go ahead and save it. Make sure it's saved. Okay. But go ahead and print it and physically turn this one in to me. Okay? I want you to have practice doing drawing sheets again. Thanks.